Hello again, this is Al. This is lesson 41 in my series, and as indicated from the last video, I want to go over a few basics before introducing the constructor and destructor concepts. The first most important thing, in fact, of all, is this idea of a reference. And I've written down questions and answers. But it's raining out there. I'm going to pause for a sec. Oh, well, it's not too bad. Okay. First, ignoring the text I've written here. The first thing to know about references, A, it's just a pointer. It's exactly 100% a pointer. If you know what a pointer is, you know what a reference is. However, there's still a great big difference between a reference and a pointer, and that's what I want to explain. First, let me just declare one, just so that you know the syntax, you can understand what I'm saying. Suppose I have an integer I, something like that. A reference declaration is done this way. Int followed by ampersand, so this means reference to int, and I'm going to call this ri. Now, this, as it is, would not compile. You cannot declare a reference symbol on its own. It has to be assigned something. So the only integer I have to assign it to in this case is I. Okay, so that should compile, turns out. Now, from this point forwards, Ri and I are essentially the same thing. That is, whatever I do to this object is going to happen to this object. But before going on, I'm going to prove to you that it is exactly just a pointer to I by declaring a pointer this way. In order to get a pointer to I say this, int star pointer to I equals address of I. I compile that, put a breakpoint somewhere. All 7. And look at the code. Okay, here's I, 7. Here's the code to create a reference to I. Okay, here's the code to create a pointer to I. Do you notice any difference? I didn't think so. Well, this uses CX and this uses AX. Now, if you think that might be important, I can turn them around. See, that's just a matter of whatever came first in the list. The first one used an A, the second one used a C. As far as this step is concerned, whatever is stored as the reference object, Ri, is exactly the same as a pointer to I. Now for the difference. A pointer, as I defined it here, if I like, I could set this equal to 0, let's say. Okay, because this is just some variable, and I can set it. But the syntax for this reference, probably best to actually step through. Suppose I try to change the value of this Ri. 8, like that. and run through this. Okay. What am I in here? Locals. So I'm trying to change RI. What happens when I do this? Well, you'll notice that, yes, it's true, RI changed to an 8, but so did I. You see, I haven't changed the fact that this thing is still pointing to I. PI, on the other hand, points to an int. I can take that away, and I can modify PI. There's nothing in the language, there's no syntax that will allow me in any way to change this value, RI. If I take the address of RI, as opposed to, and compare that to the address of I, I already have them. Let's get rid of that. Okay. Are we okay? Yes. I run through this. Now, I haven't done this step yet. PRI 12FF14. That's the address of this reference. Address of PI, exactly the same. Although the code may be different. The way that the computation is done is different. Okay. That doesn't change the fact that as far as the syntax of the language is concerned, there's absolutely nothing, no way in the world that I can ever modify this RI once it's defined. And you can only declare a reference value, it's a pointer, with an assignment. It cannot exist on its own. So in that sense, this is not a variable. Alright, so that's the major difference, is that this thing is kind of like a pointer that's not a pointer. It's a pointer, but it could never be null. It can never be invalid. It can only be set equal to something, and from that setting point onwards, that's what it is forever, the rest of its life. So that's what I've tried to explain here. The reason why it can't be altered is simple. There's no syntax which allows you to specify a new value for that identifier. There simply isn't a way of writing down please change RI to point somewhere else. There's no way to do that. So therefore, it really is something that refers to something else, and it has the added feature that, although it's possible, it's nearly impossible for a reference to be null. Certainly, in this case, it can't be null, but there are scenarios in passing things to functions where it could be possible to create a null reference, but we won't worry about that. That's rare, and that's an unusual situation, and if a function happens to have a reference value as an argument, there's no need for you to check if that thing is null or not. That's none of your fault if that's null. Okay, now what's the use? Okay. Now, as I said, internally the compiler treats it exactly as a pointer. So if you pass a variable to a, oh dear, it's the rain. I'll keep talking and go over this later. I may have to re-record this bit. If you pass a variable to a function using a reference specifier, so instead of saying int star, you say int ref. You may have noticed that I keep ignoring these functions. I've never even called them yet. That's because my intention is to either change these to references or return an actual point type object. I don't want anything that could be null passed into my functions. So that's why I'm not touching these. So if you pass something by reference, the object being passed does not need to be copied. It's simply a pointer passing. Okay, except there's going to be special pointers that can never be null. Assignment operations we looked at before, like this one here, or one on its own. This expression, okay, can be thought of as a reference to I. Okay, all assignment operations are references to the leftmost object in the assignment, the thing being assigned, in fact. And in C++, assignment for objects, non-trivial objects, like a rectangle, can be defined, a special kind of assignment. And when you create one of these, what are called overloaded, well, not very overloaded, but an assignment operator for a type, that operator, which is a function, has to return a reference to the object being assigned. That is, if we defined for a rectangle object an equals operator, so that I could say my rect, however I define it, and set that equal to another rect, something like that. This assignment is actually a function you define, and that function has to return a reference to this object, just as with integer assignment, so that this whole expression then becomes a reference to a rectangle, which could be further assigned, and so on, as we've seen before. That's why I was going on about this assignment thing, and how this is related to references. Okay, so that ampersand keyword or key symbol is designed for that, specifically for that, well, not only that purpose, but that purpose as well. Something we'll talk about later called a copy constructor. As we're talking about constructors, there's more than one type, it turns out. There's a type I showed you, taking some number of integers for the rectangle. There's one that is created by default, given this name, and you can override and make your own, is the way that an object might be constructed by copying another object. An example is just like this. Int declaration my rect r equals r. Suppose r1 was already defined. This here would invoke a special kind of constructor, which is meant to construct a new rectangle object by copying this rectangle object that already exists. Okay, there's that. And any operation on an object that an object performs on itself, let's say, which returns a reference to the same object. Now this is just a bonus thing. Can be used in compound operations using this return value to do something more. An example here is my rectangle. I might move it, and then I might want to shrink it, and I might want to put that all in one statement. If this move function returned a reference to the rect, then this whole thing becomes a reference to a rectangle, which can further be shrunk. So I can combine operations together for things provided that the function returns a reference to itself. Okay. Now, many operations actually, for a lot of objects in standard libraries, do that. Some definitely don't, like a substring type operation would not. That would just return a whole new string. But for instance, you can create post and pre-increment or decrement operators like this. It doesn't make sense for a rectangle, but you could create a plus for your object, and similarly this type of operation, and these would actually correspond to functions. Now the standard is that the pre-increment operator or decrement will increment and return a reference to the object. So this, in general, and it's true for integers as well, this here is an L value and equal to the rectangle. So you could say that if you wanted to, and it would discard whatever this did and set the value equal to 7. Not very useful, but the post version would not. A post increment function will return a copy of the object prior to the increment, and then do the increment. So if you had like rect is not a good example, but some type of object, and you wanted to assign something else to this, what's returned by this operator, the plus operator, is a copy of this object prior to the increment, which would then be assigned into here, and then the increment would occur afterwards. So that's why people tend to prefer pre-increments for some performance reason. Okay. Now I've shown you these examples pretty much. This I'll get to later. Now what I want to do, before getting on to the constructor stuff, is show you kind of an interesting little thing I made that uses some of these ideas, and I probably used too much time already. I want to keep these short. Okay, that's 20 minutes. So you have an idea what a reference is, and next time I want to show you how to use some of that reference stuff and how to define some kinds of operators for a class. I made up this class, which is integer modulo arithmetic class, integers mod 7. I don't know if you know what that means. If you're a mathematician, you know exactly what that means. Basically, it deals with just the remainders of numbers. I made a little class to demonstrate some of these ideas through this simple class. And I'll have a look at that next time. Okay. See you next time. Bye-bye.